Hello, this is Rimsky Richard, and this is a walkthrough of my hospital record project. 3 documents and 1 C++ program. A software requirement specification, a software design description, and a software test document, all built around a console app that manages patient records. I'm going to go through every single one of them in order. What it does, how the design is implemented, and what testing finds whenever we run it. And I'm going to give a quick look at the code. Uh, First things first is the software requirement specification. This follows the IEEE 830 outline. The purpose of this document is to nail down um, exactly what this piece of software is supposed to do before any code gets written or tested. Itself is scoped with a lightweight console-only utility for logging in hospital events, admissions, incidents, that kind of thing. It's only a backup tool, something you'd use if the real enterprise database connection drops, not a replacement for one. So if we go to the section 2.2, project features, this feature set is 5 menu options, a batch log set of numbers of events, where you insert an event at the very front of the log, delete most recently added, display the whole log, and exit. That's the last one, delete from it. It's worth showing now because it follows a last in first out approach. Uh, and moving on to section 2.5, design and implementation constraints. Uh, this also contains the data structure choice directly. It says the system must use a doubly linked list coded by hand as a structural list, not a library container. It's a deliberate constraint and not a suggestion. It drives a lot of the design that I decided to use for this project. And moving on to section 3.1, the functional requirements. Functional requirements break down into 4 operations: recording, sequencing, to create list loops, record attribution, capturing, which is reading the ID, name, and date fields for every single node, and then inserts at beginning logic, and a terminal destructive erasure whenever you're deleting, including explicit rules for what happens on empty lists versus a one node list versus like a longer list for section 3.2. The non-functional requirements. There are 2 non-functional requirements that are really the interesting part. Insertion at the front has to be a constant time of O of 1. There's and the delete from end is O of n. It's linear. There's also memory integrity requirements. Notes have to be released with C++ delete operator. So moving on to the SDD. That's not it. That's the code. Okay. The SDD. We have the cover page, and then there you go. We have the class diagram for the very first figure to show you how it's supposed to be ran. Uh, the design description actually covers like a broader system than the SRS did. This shows what specific events and how it all interacts with each other. Section, this is 3, yeah, 2.1. Architecturally, it's a single process, single thread console app with 3 parts. The menu that lives in main, the patient list components, the event list components. Those 2 components are completely like independent of each other. Um, so yeah, on performance constraints, Okay. Performance constraints. Uh, the design choice, like I said, was very intentional, and the DD is very upfront about it. So, like, logging an event is an event because it can append at a constant time, like every single call. Uh, but registering a patient is O of n squared because the patient list has no tail pointer. So, single registration has to walk the whole list from head just to find the n, and that's O of n squared. And for safety considerations, Section 6 on safety is honest about uh, what the program is and isn't. There's no authentication, no encryption, no persistence, no two-factor authorization. It just is a very upfront uh, piece of software. Now we go to the software test document. So the SCD tests a version of this called the Patient Record Management System. It's a single linked list, register, insert at middle, delete at middle, and display. Um, the approach mixes three techniques: black box testing, running each menu option with a valid boundary and invalid boundary. Um, Actually reading the source to find the exact like conditions and everything. So if we go to 3.2, the deflect report real quick. Mm, 2.4, this is the test procedures. Okay, for the defect report, we had 12 test cases and three defects came out of it. The first defect was critical. The pointer, like inside create lists, is used before it was ever initialized. On a normal build, uh, it can like work just because we get lucky. Um, but registering events, the very first patient inside the list, uh, it kind of made a core feature failed. Moving on to 03. This one is also critical. Again, typing in like a non-numeric character at the menu uh, makes the CN fail without ever being cleared. So the menu prints invalid choice forever and ever, and never exits, and never shows a loop again. And for my conclusion, this build isn't the most acceptable because the pass slash failure rule says zero open critical defects, and there was two, um, which is the endlessly looping of uh, invalid choice. Now we're gonna take a look at the code. So walking through the code, um, we have right here the structure of their node, which then kind of acts as our linked list node that continues to point into the next direction of whatever future nodes that we're creating. This is the function to create a brand new list for creating a brand new node that continues to point. We have our insert at mid. Uh, it literally runs as the first line in the function before position is ever read or validated. If the position check fails, the function print is rejected, and that new node is never like linked. So yeah, this was my project. Thank you so much for listening to it.